Hello everyone, welcome back to my channel. So this is the fifth video of the chapter Matrices, and in this video we'll be discussing about the different elementary operations of a matrix. So if you haven't watched the previous videos, you can check out the link of the playlist in the description box. And yeah, so let's start. Now let us see what are these elementary operations or transformation of matrices. Okay, so basically in NCRT they say that there are 6 elementary operations. Now what they mean by this is that in total there are 3 elementary operations, and the same 3 elementary operations can be applied to the rows or the columns. Okay, so basically in total you're going to have 3 elementary operations, and those 3 elementary operations can be applied either to your rows or to the columns, so that depends upon the situation. Okay, or on the sum. So let's see our first elementary operation. So in this elementary operation, the first one says that interchange of any two rows or columns. Okay, so basically suppose I have a matrix. Suppose this is a matrix. Okay, so this is a matrix, and the order of this matrix is 3 by 2, since there are 3 rows and 2 columns. Okay, so this is the matrix. Now I'm going to interchange the 2 rows. Any 2 rows we can interchange, or any 2 columns we can interchange. Suppose now this is my first row, second row, and this is the third row. So if I say that I am going to interchange row 1 with row 2, okay, I can do this step, that is I can interchange the row 1 with row 2, and still there won't be any difference. See, when I interchange the first rows, it means that this row 2 will come in place of row 1, and this row 1 is going to come in place of row 2. That means this was my first row, this is going to become my second row now, and this has become my second row, and my second row, that is 3 and 4, this is going to become my first row. Okay, so that is how I have interchanged the row 1 with row 2. Now after interchanging this, both the matrices are not equal. See, but the main thing about here is that these are the elementary operations which we are going to perform, and we are going to find the inverse of a matrix. Okay, now how to find the inverse of a matrix we'll learn now. So first we'll learn what are the elementary operations. Okay, so this is one of the elementary operations which we can do, that is we can interchange the rows. So that is how you represent it, that some ith row can be interchanged with some jth row. That is, suppose I took here that row 1 can be interchanged with row 2. Okay, similarly you can even interchange the columns. Suppose this is my column 1 and this is my column 2, so I can interchange both the columns. Column 1 is interchanged with column 2, which means that my matrix will now become like this, that the column 1 has now become column 2. So this becomes 1 3 5, and this becomes 2 4 6. Okay, so these elementary operations are going to be useful while you find the inverse of a matrix. So first let us understand what are the elementary operations that are possible. So this was the first elementary operation. Now let us see the second one. Now let us see what is the second elementary operation. Now the second elementary operation says that the multiplication of elements of any row or column by a non-zero number. Okay, so basically we can multiply the elements of any row or of any column, that is all the elements of a particular row or of a particular column, we can multiply it with a non-zero number. So that is also valid in an elementary operation. Now let me take an example. So this is a matrix, and now I'm going to multiply. Now this is the row 1 and this is the row 2. So basically according to this elementary operation, what it is saying that see, some ith row, that is some row, can be multiplied with a constant. Okay, so suppose I'm taking here row 1, and this will be interchanged in such a way that I can multiply it with some constant number, that which is not 0. Suppose let me multiply it with 2, and I can write it as 2r1. Okay, so this row 1 can be made in such a way that I can multiply all the elements of that row 1 with a number 2. Okay, any number you can take, any constant number which is not 0. So if I multiply all the elements of row 1 with 2, what is my new row 1? That is, this was my first row. So I'm going to multiply all its elements with 2. So 1 will be multiplied with 2, 2 will be multiplied with 2, 3 and 4, which means that my new matrix, that is after this elementary operations is being performed, my new matrix will be 2, 4, 3, 4. So this is my new matrix after I've performed the second elementary operation on it. That is, I've taken a particular row and I've multiplied all the elements of that row with some constant number. Suppose this is my column 1 over here and this is my column 2. Okay, so I can do the same type of operation on columns also. So basically whatever elementary operations I'm applying on rows, the same operations can be applied on columns too. Suppose if I take the second column, I can interchange it in such a way that I can multiply that second column with any constant number which is not 0. Suppose I'm going to multiply, let us say we take a number 4 and we multiply with that. So this new matrix will become in such a way that my second column, which is this is my second column, so my new second column will be in such a way that all its elements are going to be multiplied by the number 4. So this first column is as it is, 1 and 3. Second column will be multiplied by 4, that is 2 into 4 and 4 into 4. So this becomes 1, 3, 4 2s are 8, 4 4s are 16. Okay, so this is my new matrix after I've applied that elementary operation. So basically till now you must have understood this first two elementary operations. Now let us go for the third one. So this one is our third elementary operation. So at first it might seem a bit complicated, though it isn't. So we just have to go step by step. So this third elementary operation, it says that the addition to the elements of any row or column. Okay, first of all let us go with only row. Okay, the same elementary operation can be applied to column also. So in this, first of all, it says that the addition to the elements of any particular row, the corresponding elements of any other row which is multiplied by a non-zero number. So basically what we are doing is that, suppose we take a row 1 and we are going to interchange it in such a way that we can add the elements of row 1 and then we can either subtract or we can add some other row, suppose row 2, and this row 2 can be multiplied by a constant number which is not 0. Suppose I say 3 or 4 or any number which a constant number which is not 0. So this is what is the elementary operation. Or suppose I take some row 2. Now this can be interchanged in such a way that I'm going to add the elements of row 2. Then I can either add or I can subtract some other row elements, that is suppose row 3 or let me say row 4. Some other row elements can be added. Now this some other row elements that can be multiplied by a non-zero number, suppose let us say 5. So this is the elementary operation, the third one. Now the same elementary operation can be applied to the columns also, that is suppose let me take a column 4. Now this column 4 can be interchanged in such a way that I can add all the elements of this column 4, then I can either add or subtract some other column, suppose let me take a column 6. Now this column which I am either adding or subtracting, I can multiply it with a constant number which is not equal to 0, suppose let us say 7. So this is the third elementary operation. Now let us take an example and check. So I have taken an example over here. Now this is a matrix of order 2 by 2 since there are 2 rows and 2 columns in this. So I'm going to apply this third elementary operation on this matrix. Now in this, let me apply the elementary operation such a way that the row 1 can be made in such a way that I'll be adding the row 1 elements with some row 2 elements, and this row 2 elements can be multiplied by a constant number which is not 0. So let me multiply it with the number 2. So this is my elementary operation which I'm going to perform on this matrix. So here this is my row 1 and this is my row 2. Okay, so now this is going to become in such a way. Now the row 2 will remain the same as it is. Whatever the elementary operation is being applied, that is applied on the first row only. Since you can see here, this is the row 1, so all the elementary operation is being applied only on the elements of the first row, and the second row will remain the same as it is. So the first row will change in such a way that I'm going to add the elements of row 1 with the corresponding elements of row 2, and the corresponding elements of row 2 are multiplied by the number 2. So basically what I'm doing is, if you can see, this is my row 1, so I'll add 1 plus I'll multiply the corresponding element of the second row. The corresponding element here is 3, so I'm going to multiply 3 with the number 2, and that becomes my first element now after solving. Similarly, I'm going to perform the same operation on this second element. So I'm going to add this element 2 with the corresponding element of row 2, which is 4, and this 4 will be multiplied by a number 2, which was a constant over here. Okay, so this is what my row becomes. So this becomes 1 plus 3 2s are 6, that is 7, and this becomes 2 plus 4 2s are 8, that is 10, and the second row remains the same as it is. So this is my new row after applying the elementary operation, and the same kind of operation can be applied on the columns also. Now let us try the same elementary operation on the columns also. So now let me take this example. Now this is my matrix A, which contains the elements 1 2 3 and 4. Now I'm going to apply this elementary operation on this matrix. So this is my first column and this is my second column. So from this one you can see that this column 1 is on the LHS, which means that I'm applying the elementary operation on the elements of the first column, and the second column will remain as it is. So whatever I'm going to apply it on the first column, and the second column is going to remain as it is. So basically what I'm doing is, I'm going to add the elements of column 1 with the elements of column 2. But before adding with the elements of column 2, I'm going to multiply that particular corresponding element of column 2 with the number 3. Okay. So what I'm doing is, suppose if you can see here, this is 1. 1 is the first element of that column, so I'm going to add 1 plus I'm going to add the corresponding element. You can see here this one, I'm going to add the corresponding element of column 2, which is nothing but 2, and this corresponding element is going to be multiplied by the number 3. Okay, the same thing is going to be applied for the second element also, that is this 3, which is over here. I'm going to add this 3 with the corresponding element, which is 4, and this 4, that is the element of the second column, will be multiplied by the number 3, because here the constant which I have multiplied is 3. You can take any constant, but it should not be equal to 0. So when I solve this, this becomes 7 2 4 and 12 15. So this becomes 7 2 15 and 4. So this is my new matrix after applying the elementary operation on the column. So these were the 3 elementary operations. So in total there are 6, which means that the 3 elementary operations are going to be applied on columns also, and the same elementary operations can be applied on rows also. Okay. So now let us talk about invertible matrices. So in simple words, invertible matrices are those whose inverse exists. So now let us take two matrices, suppose A and B, and both of them should be square matrices, and both of them should be of the same order, let us say M. Okay, now since it is a square matrix, we know that the number of rows and the number of columns are equal, so we can denote it by a single number also. So we have taken here two square matrices of the same order M, that is A and B, and upon taking this, if this condition is satisfied, that is A into B is equal to B into A, and that is equal to some identity matrix, and the identity matrix of the same order, then we can say that B is the inverse of A and A is also the inverse of B. Okay, in a way both of them are inverse of each other. Okay, so that is what is the inverse of a matrix. Now one more important thing which comes from here is that when okay, now let me first show how to denote the inverse. See, suppose I want to say that B is called the inverse of A. So if I want to denote A inverse, I can denote it like this. Okay, A to the power minus 1, like that. So that is my A inverse, and if I want to say that B is my A inverse, then I can write it like this: B is equal to A inverse, that is B here is my A inverse. Or if I want to say that A is the inverse of B, then I can say that A is equal to B inverse, that is here A is the inverse of B. Okay, this is my B inverse, and here A is equal to the inverse of B. And in this case, this is my A inverse, so here B is equal to the inverse of A. So that is a way of writing it. Now one more important thing that comes here is that when you take a matrix, suppose A, and when you multiply that matrix with its inverse, the answer that you get is an identity matrix, and this identity matrix is also of the same order as the matrix A, and its inverse. Okay, so when you multiply a matrix with its inverse, what you get is an identity matrix of the same order. So this is also one more important thing. Now let me take an example and show. So I've taken here an example. I've taken two matrices A and B, and I'm going to find the inverse. So first I'll multiply AB, and then I'll multiply B into A, and I'll check if both of them are equal to some identity matrix or not. Basically I'm going to try to fulfill this condition over here given. So first I have to multiply AB. Now if you remember, during the multiplication of matrices, we learned one thing, that whenever we multiply two matrices, we have to check whether the columns of the first matrix is equal to the rows of the second matrix or not. So in this case, this 2 is the columns of the first matrix and 2 is the rows of the second matrix. So both of them are equal, that is 2 is equal to 2, which means that A into B, that is A and B, can be multiplied. That is possible. So when I do A cross B, I'm going to multiply the rows into columns. Okay, so we have already learned how to do the multiplication of matrices. So we are going to multiply the rows into columns. Now my first row, and this is my second row, this is my first column, this is my second column. So my first row will be multiplied with my first column and then my second column, and then I multiply the second row with both the columns. So when I multiply my first row with my first column, this becomes 2 into 2. Okay, the corresponding elements should be multiplied. Then the second element is 3, so plus 3 into the second element of first column is minus 1. Okay, then I'm going to multiply this row 1 with my second column. Okay, so when I do that, this becomes 2 into the first element is minus 3 plus 3 into the second element is 2. Now I'm going to multiply my second row, that is my row 2, with my first column, and then I multiply my row 2 with my second column. So my first element is 1, which will be multiplied with the first element of this column, that is 2, plus the second element is 2 multiplied by minus 1. Now for this one, 1 will be multiplied with this minus 3 plus 2 is going to be multiplied with 2. Okay, now when I solve this, I get the matrix, that is my final answer will be 1 0 0 1. Okay, so this is what I get finally after solving this, that is A cross B is equal to this, and this is nothing but my identity matrix. Okay, so if you remember, your identity matrix was the one in which the diagonal elements are equal to 0 and rest of the non-diagonal elements are equal to the diagonal elements are equal to 1 and the rest of the non-diagonal elements should be 0. So that is your identity matrix. So here you can see the A cross B is equal to my identity matrix. Now I'm going to do the same thing, that is I'm going to do B cross A, and I'm going to check if it is equal to my identity matrix or not. So now I'm going to do B cross A, that is B into A. So first of all, I'm going to check if the columns of the first matrix is equal to the rows of the second matrix or not. So in this case, both of them are equal, that is both of them are equal to 2. That means B into A, that is B cross A, is possible. So I'm going to multiply the rows of this matrix with the columns of the second matrix, like how we did in the previous one. This is my first row, second row, first column and second column. So first I'll multiply the row 1 with column 1, then row 1 with column 2. then I multiply my row 2 with column 1 and row 2 with column 2. This is what basically I'm going to do here. Okay, so the corresponding elements are going to be multiplied. So when I do this, 2 will be multiplied with 2 of that column, plus minus 3 is going to be multiplied with 1. Then row 1 is going to be multiplied with column 2. That is 2 will be multiplied with 3 of column 2, plus this minus 3 over here is going to be multiplied with this 2. Now row 2 into column 1, that is minus 1 into 2 plus 2 into 1. Okay, so if you don't know how to do the multiplication of matrices, you can check the playlist which is given below in the description box. Okay, so now the second row is going to be multiplied with the second column, that is minus 1 will be multiplied with 3 plus 2 will be multiplied with the 2 of that column. Okay, now when I solve this, what I get is I get an identity matrix in this case also. So if you see, in the previous case when I did A into B, I got an identity matrix. In this case also, when I did B into A, I got an identity matrix, which means that I can conclude that when I did A into B, it was equal to B into A, and this was finally equal to some identity matrix of the same order. So when I did this, this is what I got. So with this I can conclude one thing, that over here B is the inverse of A and A is the inverse of B. That is, both of them are inverse of each other. So I can write like this. So this here means that A is the inverse of B. Okay, you can see here B inverse. So it means that A is the inverse of B, and this here means that B is the inverse of A. Okay, so this is what I can conclude from this one. So this was the important step. With this I can say that both of them are inverse of each other. So time for some important points on this topic. Now these important points can come as 1-mark questions in your board exams. So the first point says that inverse of a square matrix, if exist, is unique. Now first of all, what does this point mean is that if you have a square matrix, there are two possibilities. Either the square matrix can have an inverse or it cannot have. Okay, it does not mean that every square matrix is going to have an inverse. Okay, that is not compulsory. A square matrix will have inverse, but not all square matrices will have. So if suppose I have a matrix A, then its inverse will be unique. That is, suppose B is its inverse. Okay, so suppose B is the inverse of the square matrix A. Now I cannot have another matrix C which will also be the inverse of A. Okay, so if there is a matrix and it is going to have an inverse, then that inverse is going to be unique. That is, every matrix will have only one inverse, not more than that. Okay, so this was our first point. Now the second point says that a rectangular matrix does not possess inverse matrix at all. Okay, so if you know, in a rectangular matrix, it can never have an inverse. Okay, so like a rectangular matrix is one like in which the rows and columns are not equal. Okay, so they are unequal. So in that the inverse of a matrix is not possible. So it can only be possible in case of square matrix, and in that also it does not mean that every square matrix is going to have an inverse. Okay, only in certain conditions where this thing is where this condition is satisfied, that is A into B is equal to B into A, and that is equal to some identity matrix. If this condition is satisfied, then you can say that the inverse of a matrix is possible, right? That is, that particular matrix is having its inverse. Okay, now there are other ways also to find it. So now let us go step by step. Now the third point says that if B is the inverse of A, then A is also the inverse of B. So this one we saw with our previous example, that if there's some matrix B and that is the inverse of A, then we can say that A is also the inverse of B. Okay, that means both of them are inverse of each other. Now the fourth point is basically is a statement that if you do A into B and then you take the whole inverse, then that can be equal to the B inverse into A inverse. Now if you write this as A inverse into B inverse, then it will not be equal. Okay, so if you do B into A and if you do A into B, it means there's a difference in that. Okay, so you have to take care which is your first matrix and which is your second matrix. So this one, that A into B and then you take their whole inverse, will be equal to B inverse multiplied by A inverse. So these were some 4 important points that you have to remember. So that's all for this video, and now in the next video we'll be learning about how to find the inverse of a matrix by using the elementary operations which we discussed in this video. And we will also solve some previous year questions, okay, good questions of board exams. That all will happen in the next video. So if you have any doubts, you can let me know in the comment section below. So thank you for watching and meet you in my next video.